The ratio of tensions on the tight side to that on the slack side in a flat belt drive is proportional to the product of coefficient of friction and the lap angle. An exponential function of the product of coefficient of friction and lap angle theta proportional to the lap angle proportional to the coefficient of friction. We know that the ratio on the tight side is T1 by T2 is same as e to the power mu theta. So it's clearly a exponential function of the product of coefficient of friction and the lap angle theta. Choice B is correct choice. The percentage improvement in the power capacity of a flat belt drive when the lap angle of the driving pulley is increased from 150 to 210 by an idler arrangement for a friction coefficient of 0.3. So initially we have angle of contact equal to 150, and if we use the idler then the angle of contact become 210. You have to calculate here the percentage change in the improvement of the power capacity. So we'll consider two cases here. One is without idler and with idler. In the case of without idler, the contact angle theta is equal to 150. So we have theta is equal to 150 degrees. And when we are using the idler, that time we'll find that the contact angle has been increased and this value become equal to 210. Coefficient of friction in both cases, that is the value of mu, is remain same, that equal to 0.3. Here also the value of mu is remain same, that equal to 0.3. Power transmitted is given as T1 minus T2 multiplied by linear velocity v. So if I take out here T1 common, then I left here 1 minus T2 by T1 into the velocity v. So let's consider here we have mu into theta. In the first case, that is theta A is equal to 0.3 multiplied by 150 multiplied by pi divided by 180. So in the first case, we will get the answer equal to 0.785. Similarly, the product of mu into theta b, that is in the second case, will be equal to 0.3 multiplied by 210 multiplied by pi divided by 180 is approximately equal to 1.11. The maximum allowable tension T1 is always fixed. So only the value of T2 by T1 will change in this case, which was nothing but e to the power mu theta. So this time the power is proportional to 1 minus T2 by T1. So we need to calculate T2 by T1 for both cases. So we can calculate here the ratio of tension of a tight side to slack side, that is T1 by T2 is same as e to the power mu theta. That is we have e to the power 0.785. So T1 by T2 will equal to 2.19, and hence we can calculate the value of 1 minus T2 by T1. So we have 1 minus T2 by T1 is equal to 1 minus 1 upon 2.19. So this answer is equal to 0.544. Same procedure will repeat here also. This time the tension will change. That is, the tension on the slack side will change. Tension on the tight side will remain same because that is the maximum tension. So let's represent it as T2 prime. This value is same as e to the power mu into theta b. That is, we have e to the power 1.1 is equal to 3.004. So we can calculate here 1 minus T2 prime by T1 is equal to 1 minus 1 divided by 3.004. This value equal to 0.667. So we can calculate here the power transmitted with idler is PB divided by power transmitted without idler is PA is equal to 1 minus T2 prime by T1 divided by 1 minus T2 by T1 is equal to 0.667 divided by 0.544 equal to is approximately equal to 1.23. So there is an increase of 23%. As far as the choice is considered, choice A is closely matched. Which one is 25.21? A belt drive is shown in figure A, has an angle of wrap equal to 160. Adding an idler as shown in figure B increases the wrap angle to 200. The slack side tension is the same in both the cases and the centrifugal force is neglected. So this time the value of T2 is remain same, the value of T1 will change. By what percentage is the torque capacity of the belt drive increased? By adding the idler. Previously we have taken the value of T1 constant, this time we have to keep the slack side tension constant. So we have theta A is equal to, that is without idler, the angle of contact equal to 160. You have to always use this in radian, that is 160 multiplied by pi divided by 180, which is equal to 2.7925. In the second case, we have theta B is increased to 200. Again you have to multiply by pi and divide by 180 to convert into radian. So we have theta B is equal to 3.490. The coefficient of friction in both cases you have to take as 0.3. So in the first case it is 0.3, as well as in second case is also equal to 0.3. And this time the slack side tension is same. So what is the value of T2? And the value of T2 in both cases is same. In first case we have tight side tension is T1, second time it is T1 prime. We have to find out the percentage in the torque carrying capacity. Now here the torque is given as the difference between the tension in tight side minus tension in the slack side multiplied by the radius of pulley. Now since here T2 you have to remain same, so I will take out T2 common. What is left is T1 by T2 minus 1 multiplied by R. So torque is proportional to T1 by T2 minus 1. Therefore we have torque in the second case with idler divided by torque in the first case without idler is equal to T1 prime by T2 minus 1 is divided by T1 by T2 minus 1. So we need to calculate the value of T1 prime by T2 and T1 by T2. So we have T1 by T2 is same as e to the power mu theta, which is same as e to the power mu equal to 0.3 and value of theta equal to 2.7925. So in the first case I will get the ratio of T1 by T2 equal to 2.31, and when the idler is provided then we can calculate T1 prime by T2 is equal to e to the power mu theta, which is 0.3 multiplied by 3.49. This value of the ratio is 2.849. So just substitute this value and we have to solve this. So let's substitute here the value of T1 prime by T2 prime is 2.849. 2.849 minus 1 divided by T1 by T2 is 2.31 minus 1. So this answer is close to 1.4125. So this fraction value represents here the increase in the torque capacity multiplied by 100, that equal to 41.25% increase in the torque carrying capacity. The difference between the tension on the tight and the slack side of a belt drive is 3000 Newton and the belt speed is 15 meter per second. power transmitted in kilowatt we have to find out. We have difference between the tight and the slack side, that is T1 minus T2 is given as 3000 Newton. And we have linear speed V is given as 15 meter per second. This is a straightforward question in which we have given the difference in tension and we need to calculate power. So power is same as T1 minus T2 multiplied by linear velocity V. We have T1 minus T2 is equal to 3000 multiplied by velocity is 15. This answer will come in watts. So you have to divide this by 1000. So our answer is 45 kilowatt. A flat belt open drive transmits 1.5 kilowatt of power. The coefficient of friction between the belt and the drive pulley is 0.25. Lap angle is given as 159. The drive pulley is rotating in a clockwise direction with a linear velocity, that is the belt velocity is 3.75 meter per second. Determine the X and Y component of the reaction on the drive pulley shaft. We have given the power transmitted is equal to 1.5 kilowatts. So we have power is equal to 1.5 kilowatt. Coefficient of friction mu is known, that equal to 0.25. Angle theta is given, that is lap angle is given is equal to 159, that you have to use in radian. The drive pulley is rotating in a clockwise direction. So it is rotating in a clockwise direction. And we have linear velocity V is given as 3.75. Now about the direction of the slack side and the tight side. The slack side tension T2 opposes the direction of motion. This time the motion is a clockwise. So this direction will oppose the direction of motion. So this one is representing the slack side T2 tension. And the tight side tension T1 always act in a direction of motion. So motion is clockwise. So this tension will be same as equal to T1. First you have to find out the value of T1, T2 and then we'll check the reaction by resolving the T1 and T2 along the horizontal and vertical direction. To calculate here the power, first we'll find out the ratio between T1 and T2. T1 is the tension on the tight side divided by T2. The tension on the slack side is equal to E to the power mu multiplied by theta. On the right hand side we have E to the power mu. Mu is equal to 0.25. Theta you have to use in radian, which is equal to 159 multiplied by pi divided by 180. So we have a ratio is equal to exactly equal to 2. And the power transmitted P is given as the difference between the tension on the tight side minus tension on the slack side multiplied by linear velocity V. Power you have to take in watts is 1500. This time T1 we can replace as T1 is replaced as 2 times of T2 minus T2 multiplied by the velocity V, which is equal to 3.75. Which one is meter per second is correct unit, 3.75. So we have 1500 divided by 3.75 will give the value of T2 and we get the value of T2 close to 400 Newton. Again we can find out the value of T1, which is 2 times of T2 will be equal to 2 into 400 is 800 Newton. So let's represent here the tension T1, which one is on tight side, tension T2 on the slack side. This total angle equal to 159 is divided into 2 parts, that will be 79.5. So this angle is same as 79.5 as well as this angle is also 79.5. These are the tangents. T1 and T2 are the tangents. So this angle is equal to 90 minus 79.5. 90 minus 79.5, that equal to 10.5. So this angle is same as equal to theta as well as this angle equal to theta. The corresponding angle here is also equal to theta. So this component is same as T2 cos of theta, that is 10.5. Whereas this component of T1 is T1 into cos of 10.5. The vertical component here, which is acting downward, is T1 into sine of 10.5. And the vertical component of T2 is T2 into sine 10.5. We are interested to know the X and Y component reaction on the drive pulley. So let's say we have reaction along the X direction is Rx and the reaction along the Y direction is Ry. We'll consider here the X-axis as a horizontal and the Y-axis as vertical. Since here for equilibrium we have sigma Fx rightward must equal to 0. So Rx value will be taken as positive. Then T2 cos 10.5 is a negative value and T2 is equal to 400. So we have 400 into cos of 10.5 minus T1, which is equal to 800 into cos of 10.5 is equal to 0. Using this we can find out the value of Rx. So this reaction come out to be 1180 Newton. And the answer is positive, means the assumed direction is correct, that is rightward. Then we'll use the value of sigma Fy, which one is vertically upward positive, must equal to 0 for equilibrium. Ry value is shown upward is positive value. Then T2 sine 10.5 is upward is positive value. And we have value of T2 is equal to 400. So we have 400 into sine of 10.5. T1 value is acting downward. So we have minus T1 is 800 sine of 10.5 must equal to 0. So you have to calculate the value of Ry, which come out to be positive value, is close to 72.89 Newton. So he is only interested in the X component and Y component. So X component is come out to be 1180 Newton and the Y component come out to be 72.89 Newton. Now this part is important for us. Slack side tension T2 always opposes the direction of motion and the tight side tension T1 always act in the direction of the motion. So whenever he gives the motion, then you have to first decide T1. So you have to take the T1 as same as the direction of motion and T2 you have to take exactly opposite. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.